We're going to do exactly like example 1 for this section. I'm just going to do a little bit change. This is like example 1. So I'm going to choose this matrix, and these examples are from the book. So just a little bit change is 1, 1, 0, 0, negative 3, and 1, and 0, 0, 4. So when they ask you here, find, we're going to do exactly the same thing when they ask you here. We need to use the characteristic polynomial or equations to find the value of lambda. So it's going to be lambda 1, lambda 2, and 3. We can work on this one. Let's do the same examples here. So when you plug in negative 6, and here is 4. This one is 7. Let's work on this one. So the determinant for a minus lambda I is going to be equal determinant of the matrix A, which is 1, 1, 0, 1, 1, 0, 0, negative 6, 1, 0, negative 6, 1, and 0, 0, 7, minus lambda with the identity matrix with the 3 times the 3. So it's going to be 0, 0, 1. To find the lambda, that means the determinant for this matrix equal 0. So let's 1 minus lambda I, combine these together. So it's going to be the determinant of the matrix 1 minus lambda and 1 here, 1 minus lambda, and this is going to be just 1 because here is 0. So it's going to be 1, 0. And the other one is going to be 0. And here is going to be negative 6 minus lambda. And this one is going to be 1. And the last row is going to be 0 and 0 and 7 minus lambda. What I'm doing, I'm multiplying and combining these together. So this one is going to be 0, 0, and here the last row is 7 minus lambda. The determinant for this one equals 0. Now we're going to find the determinant for this matrix. So I'm going to say this is a plus, this is minus, and this is plus. That means we don't have to write down determinant anymore because we're going to find it. So here is the first element, 1 minus lambda. And the matrix is going to be negative 6 minus lambda, and 1, and 0, and 7 minus lambda. Minus 1, the second element, so cancel this column and this row. So it's going to be 0, 1, 0, lambda. So it's going to be 0, 1, and 0, 7 minus lambda. Plus 0, 0 times any number is going to be 0. I'm going to write down this one, it's okay. But this side is going to be all zeros. And here is 0, 0. So this one, all determinant equals 0. Because we need to find the eigenvalue. This side is 0, negative 1, 0, minus 0. So this one 0 times negative 1. So everything here is also 0. Let's work here. That's mean 1 minus lambda. And this one is going to be the multiplication of negative 6 minus lambda times 7 minus lambda minus 0. Because 1 times 0 is going to be 0, equal 0. Now we have to simplify this side. If you look to this one, it's already factored. Why are you going to distribute? Then you're going to factor it again. That's mean 1 minus lambda and negative 6 minus lambda and 7 minus lambda is equal 0. In this case, we have a 3 lambda equal 1, and here lambda is going to be equal -6, and here lambda is going to be equal 7. That means here's the eigenvalue for this example. We're gonna start. I'm gonna say this is lambda 1, and here's, let's say this is lambda 1, -6, the smaller one, because they ask you to start from the smaller lambda value. So I'm gonna write down -6 here as a lambda 1, and here is 1 and -7. And lambda 2 here, and here is lambda 3. Now we need to find the eigenvector or eigenspace. And the eigenspace is that means you're going to find the null space. How to find the null space? By solving for x1, x2, and x3. First of all, when lambda 1 equal -6, the smaller one, I'm going to plug in -6 here. So, and solve it for x1 and x2 and x3. So -6 here, that means the matrix is going to be 1 minus -6. That means 1 minus -6. And here is 1, 0. This is 0. -6 minus -6. -6 minus -6 for the second row, second column. -6 minus -6. And here is going to be 1. The third one, 0, 0, and 7 minus -6. This one is going to be equal. I'm going to write down the matrix and solve it for x1, x2, x3. So this one is going to be 7 and 7, 1, 0. And here's 0. This one is going to be 0, and here's 1. And the last one is going to be 0, 0, and 7 plus 6 is going to be 13. I'm going to solve it right away to find the null space. I need to solve this one for x1, x2, x3. So if you look here now, we just have to reduce this matrix by the row echelon form. So what I'm going to do, I need to convert this one to 1. So I'm going to say R1 is going to be the old one divided by 7. So the first thing what I'm going to do, I'm going to say this one is going to be 1 over 7. And here is still 0. And this one is 0. And then the next row is going to be, give it this 0, 0, 1, and 0, 0, 13. I'm done from the first row, convert the leading entry to 1. All the elements under the leading entry is zeros, so that's it. Now I'm going to go to the second leading entry, which is here. This is the second leading entry. I'm going to convert everything under the leading entry to 0. That means what I'm going to do, I'm going to say R3 is going to be -13, R2 plus R3. That means the new matrix is going to be 1, 1 over 7, 0, 0. And the second one is going to be 0, 0, 1, and here is 0. The third one just is going to be all zeros. Now we're done. Let's find the null space x1, x2, and x3. That means x1 plus 1 over 3, 1 over 7 x2 is going to be equal 0. So in this case, x1 is going to be -1 over 7 x2. And we have x3 equals 0. So x3 is 0. It's just a fixed number. x1. So in this case, we're going to let x2 equal t. That means x1 is going to be -1 over 7t. So this is the eigenspace, which is the same thing, the null space, x1, x2, x3, which is equal. x1 is -1 over 7t, -1 over 7t, and x2 is 0, x3 is, no, x2 is t, and x3 is 0. If you let t equal 1, that means the eigenspace is going to be -1 over 7, 1, and 0. Or you can type it like this. Multiply by 7, so it's going to be -1, 7, or 0. -1, 7, and 0. So this is for this eigenspace. When eigenspace lambda equal -6, the eigenspace, which is the null space, is going to be -1, 7, and 0. Because x3 is, I think we can check that, yes. For the multiplicity for this one, if you look to the eigenvalues, they are totally different. It's not repeated. That means all these old multiplicity. So the first one, we got the first one. With the first lambda, the old multiplicity is 1, and the geometric multiplicity also 1. Let's go when lambda equal 2. We're going to do the same steps. When lambda equal 1. So I'm going to plug in 1 here. That means there's going to be the matrix 1 minus 1. And here is 1, 0, 0, -6 minus 1. And here is 1. This is 0, 0, and 7 minus 1. Simplify it and try to find the null space. So it's going to be 0, 0, 1, 0, and here is -7, 1, 0, 0, 6. So we're just going to solve it for lambda equal 1. We have 0. There's something wrong. This is 1. The 1 is here. So now we're just going to do the same thing. We're going to reduce this one to the row echelon row echelon 4. That means the first leading entry is this one. I'm going to convert the 7 to 0. So I'm going to say R2 is going to be 7 R1 plus R2. Because we're going to follow the leading entry, which is this one. That means it's going to be 1, 0 here, 1, 0, and this is 0. This is 0 is going to be 0, -7 times R1, and this one is still 1, and here is 0. And here is the third row. Now the second leading entry, this one, so I need to convert this one to 0. So what I'm going to do, R3, -6, R2 plus R3, which is going to be all zeros here, 1, 0, 0, and 0, 1, 0. That means x1 is going to be 0. There's no x1. It's supposed to be any number. Any number with x1. x2 equals 0, and x3 equals 0. So x1 is any number, x2 equals 0, and x3 equals 0. So x1, x2, x3 is going to be equal. Let x1 is t, and let t equal 1. That means this is t 0, 0. Then this one is going to be equal 1, 0, 0. So this is the eigenspace, which is the span of 1, 0, 0 for the second eigenvalue, which is 1. So we're going to check that, and we're going to jump to the next one. The next one, to find when lambda equal 3, the multiplicity, the same thing, because it's not changed. There is no multiplicity here is 1 and 1. It's not repeated. That means the multiplicity is going to be 1. For this one, when lambda equal 7, that means we're going to plug in 7 now in the characteristics polynomial. So I'm going to write down this right away. So 1 minus 7 is going to be -6. And here is 1, 0. And here is 0. -6 minus 7 is -13. This is 1, 0, and 0. And 7 minus 7 is going to be 0. We're just going to solve this one for x1, x2, x3. So this one is going to be -6, 1, 0, 0, -13, 1, 0, 0, 0. Solve it for x1, x2, x3. The first leading entry is -6. So I'm going to reduce that. R1 is going to be the old one divided by -6. So the new matrix is going to be 1, -1/6, 0. And here is going to be 0, -13, 0, and all zeros here. But let's check because we're dividing. Okay. The next step, all here zeros, the second leading entry is going to be this number. So we're going to convert this number to, so R2 is going to be R2 divided by -13. That means this one is going to be 1, -1/6, 0. And here is going to be 0, 1, 0. And here all zeros. That means x1 minus 1/6, x2 is going to be 0. So in this case, x1 is going to be 1/6, x2. And x2 is going to be 0. That means x1 is the same thing because you're going to plug in 0 here. So it's going to be, there's something wrong because this is 1. I converted to the 0. This is 1. And this is 1. Because we don't have to get the same one for the first eigenspace, for the second eigenspace. So the second x1 minus all of this, right? Now we have x2 plus x3 is going to be 0. That means x, let's say x3 equal -x2. -x2. So in this case, we're going to let x2 equal t. So x1 is going to be 1/6t, and x3 is going to be -t. So that's mean x1, x2, and x3 is going to be equal. x1 is 1/6t, and x2 is t, and x3 is -t. Let t equal 1. So it's going to be 1/6. And here is going to be 1 and -1. Let's see. We have divide by 13. Yeah, we still have something wrong because when I divide this one by 13, this number is going to be -1 over 13. Yeah, that's totally different. So this one is going to be minus 1 over 13 x 3, which is equal 0. In this case, you have to solve it for x2. It's more than one operation, so you have to be careful. So x2 is going to be 1 over 13 x3. We're going to plug in this one here. That means x1 is going to be 1 over 6 times 1 over 13 x3. So x1 is going to be 1 over 6 times 13, which is equal 78. So 1 over 78 x3. So here is x1, and here is x2, and x3 now is going to be any number that's equal t. So that's mean x1, x2, x3 is going to be 1 over 78t, and x2 is 1 over 13t, and x3 is equal t. Let t equal 1, 1 over 78, and here is 1 over 13, and here is going to be 1. Multiply by 78 to cancel the fraction. So it's going to be, here's 1, and here's going to be 6, and here's going to be 78. That means this is the eigenspace for the third eigenvalue when lambda equal 7. So when lambda equals 7, the eigenspace is 1, 6, and 78. 1, 6. Yeah, cross divide. 78 by 13 is going to be 6. 78. And multiplicity, the same thing, 1 and 1. That's it for this. And that's what we're going to do with the next example. With the next example, we have a 318. You're going to do exactly the same thing, but when you got repeated lambda, like for this example, in case if you have 2 lambda like 0 and 0, you're going to type 0 here and 0 here. And the same eigenspace, like the same number is going to be here and the same number is going to be here. But the multiplicity for the first one is going to be 2 because it's repeated twice. 1, 2. That this is just in case. If you have the same lambda, you're going to put down 0 here and 0 here. And you're going to get the same eigenspace. But for the multiplicity, you're going to type 2 here and 2 here. I think we can do this example. So determinant for a minus lambda I equals 0. That means is going to be the determinant of a, which is 2, 0, 3, 4, -1 and 4, 3, 0, 2, minus lambda I, which is lambda 0, 0, 0, lambda 0, 0, 0, lambda. Everything equals 0. So now that means it's the determinant of this matrix, which is 2 minus lambda and 0, 3. And here is 4, -1 minus lambda, and 4. The last row is 3, 0, and 2 minus lambda equals 0. So if you look to this one, now we're just going to find the determinant for this one. So this is a plus, minus, a plus. And that's the important thing here when you find the eigenvalue. Because we already learned how to find the eigenvalue, but how to factor the polynomial when you get the polynomial function. So now the first one is going to be 2 minus lambda, and cancel this row and this column. So it's going to be -1 minus lambda, and 0, 4, and 2 minus lambda, plus minus 0. That means this one is going to be, the whole thing is 0, plus 3, which is here, is going to be cancel, 4, -1 minus lambda, and 3, 0. The whole thing is equal 0. The second part is cancelled. So now it's going to be 2 minus lambda. And here is going to be -1 minus lambda times 2 minus lambda minus 0. Because this times this one minus 0. Plus 3. The same thing here is going to be 0 minus 3, -1 minus lambda. Now we have to distribute here because we have two parts. We can't leave this part separate than this one. So we have to combine everything together, then we're gonna factor it. So here is 2 minus lambda, and here on this side, we're gonna distribute. So it's going to be -2 plus lambda minus 2 lambda plus lambda squared. And here is a plus. This is 3. We're going just to distribute this one. It's 3 plus 3 lambda equals 0. Then the next step, combine everything here together. So it's going to be 2 minus lambda. And here is going to be lambda squared minus lambda minus 2. Plus, distribute the 3. It's going to be 9 plus 9 lambda equals 0. Now we're gonna distribute here, and the rest we're gonna add it with this one. So here is going to be 2 lambda squared minus 2 lambda minus 4. 2 times -2 is going to be -4 minus lambda cubed plus lambda squared plus 2 lambda plus, I'm done. -2 times negative lambda times -2 is going to be +2 lambda plus 9 plus 9 lambda equals 0. Now we're going to combine the like terms. This is by itself, squared, and this is cancel with this one. We just have 9 lambda. That means it's going to be negative lambda cube plus 3 lambda squared. Because we have lambda squared here. This is also lambda squared. Oh yeah, we cancel the lambda. So it's going to be 3 lambda squared plus 9 lambda plus 9 is going to be equal 0. And that's, now we didn't finish, we're just finding the lambda. So the next step, how are we going to factor this one? So let's check how we're gonna factor this one. To factor this one, we're gonna use the synthetic division. That's how we're gonna factor this one, by using synthetic division. So A naught always is the coefficient of the constant. A naught is the constant. Let's check here. We have something wrong because this is not 9. -4 plus is going to be minus plus 5. Because -4 plus 9 is going to be plus 5. Okay, now that's okay. You can, before you start, just take the negative sign out. So it's going to be lambda cubed minus 3 lambda squared minus 9 lambda minus 5 is going to be equal 0. Now, how are we going to factor this one? By using synthetic division. A naught is the constant, which is -5, or just type 5, it doesn't matter. An is, I'm using synthetic division. An is the coefficient here, the leading coefficient, which is 1. P is going to be the factors of -5, which is a plus or minus 1, plus or minus 5, because 1 times 5 is going to, 1 times -5 is going to be -5. -1 times +5 is going to be -5. So the factors for number -5 is these two numbers. Q is the factors of 1, which is a plus or minus 1. Now, the rational principles zeros is going to be P over Q. 1 divided by 1, positive or -1. 5 divided by 1 is going to be positive or -5. That means we have 4 options, so we can factor this polynomial with degree 3. I'm going to start with the first one. I'm going to start with k equal -1. K equal 1, and I'm going to use the synthetic division. The first thing, there is no missing term here. Cube, squared, 1, and 0. So the coefficient here is 1, -3, -9, and -5. And I'm going to write down k here, which is 1. This is the first number. 1 times 1 is going to be 1. Not here. 1 times 1 is going to be 1. Add these two numbers together is going to be -2. 1 times -2 is going to be 2. -2. Add these together is going to be -11. 1 times -11, -11. Add these together is going to be -16. The remainder here is not 0. That means this one is not a factor for this polynomial. Let's do the same thing with k equal -1. You have to know this method. This is the synthetic division. So here's -1. I'm going to write down the same thing, 1, -3, -9, and -5. Now write down the first number, -1 times 1 is going to be -1. Add these two numbers together, -4. -1 times -4 is going to be 4. Add these two numbers together is going to be -5. Now -1 times -5 is going to be 5. Add these two numbers together is zeros. So 0 is the remainder. That means x plus 1 is going to be a factor for this polynomial. Then this number is going to be the constant. This number is going to be the x, and this number is going to be the x squared. So let's write down this polynomial as this one times this one. Here's our new polynomial. Why I put down x? Because we have to write down with lambda. That means this is lambda, and this is lambda squared. So let's keep going. That means the polynomial function this one, which is negative lambda cubed plus 3 lambda squared plus 9 lambda plus 5 equals 0 is going to be, the first factor is going to be, here is the negative, lambda plus 1. This is lambda, not x, because our variable is lambda. And the left here is going to be lambda squared minus 4 lambda minus 5 as a constant equal 0. Now, if you look to this one, it's easier to factor because it's a quadratic. So negative, here is lambda plus 1. I'm going to open 2 parentheses equals 0. Negative 5, I'm going to put 5 and 1. Negative, positive. Negative 5 lambda and 1 lambda is going to be negative 4. So if you look, we have exactly the same thing here. That means negative lambda plus 1 squared, and here is lambda minus 5 equals 0. So here is the factors for this polynomial. That means we have lambda 1 equal negative 1, and lambda 2 equal negative 1 also, and lambda 3 is going to be equal 5. Check, here is lambda 1, lambda 2. This is going to be even multiplicity, and this one is going to be even multiplicity because we have exactly the same number. So even, and this is odd. So when lambda equal negative 1, is going to be we're going to plug in lambda equal negative 1 in the characteristic polynomial, which is, I put the page. So plug in the characteristic polynomial, which is going to be, I'm going to write down this IOA, 3, 0, 3, and 4, 0, 4, and 3, 0, 3, 0, 0, 0. I'll solve this one. We're just going to change R1 is going to be the old one divided by 3. So it's going to be 1, 0, 1/3. And here is 0. The second one is going to be 4, 0, 4, and 3, 0, 3. Now, next step, I'm going to do 2 operations at the same time. I'm going to say R2, negative 4, R1 plus R2. And R3 is going to be negative 3, R1 plus R3. So the new matrix is going to be is going to be 1, and here is 0, 1 over 3, 0. So negative 4 times and a plus is going to be 0, 0. Negative 4 times negative 4. Oh, we're dividing by 3. So this one is 1. That means this is going to be 0, 0. And the same thing, we're going to multiply negative 3 times R1 plus this one is 0. Negative 3 times this one is also 0. And this one is also 0. And this is 1. That means x1 plus x3 is going to be equal 0. In this case, x1 is going to be negative x3. So x2 is any number. X2 is any number. That's me. This is really important. I'm going to let x3 equal t. So x1, x2, and x3 is going to be equal. x1, negative t. So negative t. And x2 is 0. I'm going to let x2 equal 0, then x2 equal 1. And flip it, because now we have x2 is any number. We're going to let's say x2 equal s. And I'm going to let s equal 0, then s equal 1. And t, the opposite thing with the x and t. So now this is 0. Let's write down in general. That's mean s. And the last one is going to be t. So we have two eigenspace. Be careful here. So when s equals 0 and t equal 1, that means x1, x2, x3 is going to be -1, 0, and t 1. Then s equal 1 and t equal 0. That means x1, x2, and x3 is going to be x1 is going to be 0, 1, and 0. So the span of the eigenspace is going to be -1, 0, 1, and 0, 1, 0. This is now the span for this eigenspace. So here, when lambda equal 5, we're going to plug in this one in the matrix with the characteristic equations. So it's going to be -3, 0, 3, 0, and 4, -6, and 4, and here is a 3, 0, and -3. And the numbers here, zeros. Now, the next step is going to be convert this number to 1. So I'm going to say R1 is going to be R1 divided by -3. So it's going to be 1, 0, -1. And here is going to be 4, -6, 4, 3, 0, -3, and zeros here. Now the next step, I'm gonna do two operations on the same time to convert the 4 and 3 to zeros. So I'm gonna say R1, R2 is going to be -4 R1 plus R2, and R3 is going to be -3 R1 plus R3. That means the new matrix is going to be 1, 0, -1. And these are two zeros, -6, and here, because -4 times is going to be +4, plus 4 is going to be 8. There's 0, and here is going to be two zeros. Now, the second leading entry, which is this one, we're just going to divide R2 by -6. So the new matrix is going to be 1, 0, -1, 0, 1, -4 over 3, and the last row is going to be all zeros. Then x1 minus x3 is going to be equal 0. That means x1 is going to be equal x3. And x2 minus 4 over 3 x3 is going to be 0. So x2 is going to be 4 over 3 x3. So we're going to let x3 equal t. That means x1, x2, and x3 is going to be equal. X1 is going to be t, and x2 is going to be 4 over 3t, and x3 is going to be t. Let t equal 1. So in this case, it's going to be 1, 4 over 3, and 1. Convert, simplify the fraction times 3. So it's going to be 4 times 3. So it's going to be 3, 4, and 3. So this is the span, which is 3, 4, 3. That's it for this example. First of all, I'm gonna show you how to solve it, then how we're gonna find a to the power 8, because that's our goal, to find a to the power 9x. So first of all, we already know that a v1 is the same thing lambda 1 v1, and a v2 is the same thing lambda 2 v2. So these what we're gonna check as a base. That's mean every time when I need to find a with the v1, I can use lambda 1 v1. But v1 as a vector, so that's what we're gonna find first. We have x. We need to find the x because we don't have the x. That's our goal now, the first step. X is a vector I can write down as a linear combination from these two vectors. So x is c1 v1 plus c2 v2. Then the first step, I'm going to find c1 and c2 so I can find the vector x. So x is 9 and -1 equal c1 with the vector v1 1 1 plus c2 with the vector 2, which is v2 v1 is negative this, and v2 is 1 1. So now I'm gonna get two linear equations. 9 equal of c1 plus c2 equal 1 equal 9, and the second one I'm gonna get c negative c1 plus c2 equal -1. Solve this one. So it's going to be 2c2 is going to be equal 8. That means c2 equal 4. Plug in 4 here. So c1 plus 4 equal 9. That means c1 equal 5. So now I have c1 and c2, so I can write down the vector x. So the vector x is going to be equal c1 v1 plus c2 v2. That means x is going to be c1 is 5, V1 plus C2, which is 4. So this is the vector X. That's what I'm going to use. Now, the theorem says A to the power 9 X is going to be equal. I have the X, and here is A to the power 8. We don't have the matrix A, so it's going to be, we're just going to say A to the power 9 times the X, which is 5 V1 plus 4 V2. That means we're going to distribute is going to be 5 A to the power 9 V1 plus 4 A to the power 9 V2. Then here is what we're going to use the theorem. A V1 equal lambda V1. That means A equals the lambda, the eigenvalue. So if you have A to the power 9 is going to be equal lambda to the power 9. That means this one is going to be 5 lambda to the power 9 V1 plus 4 lambda to, be careful here, this is lambda 1 and here is lambda 2 to the power 9 with respect, here's V2. So it's going to be 5 lambda 1 to the power 9 is going to be half to the power 9 plus V1. Don't forget V1, which is the vector 1, -1. Plus 4 lambda 2, which is 2 to the power 9 V2, which is 1, 1. Now this is easier to work on. 2 to the power 9, 256, I think. 2 to the power 9 is going to be 512. That means this is 5 times 1 over 512 times the vector 1 and -1 plus 4 times 512, 1, 1. Then we're just going to simplify this one. We can divide this one. So the whole thing is going to be here 5 over 512. And here's -5 over 512. You're going to add with this vector 4 times 512 is going to be 2048 times 1. So here's 2048 and here's 2048. Then we just have to add these together. So 512 and this one is going to be 5 over 512. We can't do this one because it's not going to be fraction, it's going to be decimal. So we have to do it on the side. That's mean 5 over 512. You're going to add 248 over 1. You're going to multiply this big number by 512. It's going to be 5 over 512. You're going to add 104,856. And you're going to add, here's 512. So you're just going to add 5. So it's going to be the result here on the top. And the same thing, you're going to minus 5. It's going to be 104,851 over 512. And the same number, you're just going to say minus 5 is going to be 71. That's mean 10 4, 8, 5, 8, 1, not A1, 7, 1 over 5, 12. That's it for this example. But that's how we're gonna find. So the first one is going to be fraction with 1048581. 8581 over 512. And the second one is going to be 104858858, no, 8571. 8571 over 512. Did I click on it? The same thing is going to be with the next example. Here we go. Mistakes. The negative sign is outside. 1 over 3 to the 20. So here is minus. I can keep it inside. I can put the negative sign inside because it's going to be positive. And then the result is going to be plus. So it's minus here. And the last one is going to be 4. The last example is another theorem. And here's the theorem. They're telling you the companion matrix of P of X is this one. Here's the companion matrix, which is negative an minus 1, negative an minus 2, and keep going. Where they're telling you here, find the companion matrix of P of X for this polynomial. That means we have to locate an minus 1 and keep going. So the polynomial function is P of X. This is example 7. P of X equal x cubed plus 4x squared minus 5x plus 15. Minus 5x plus 15. Be careful, there is no missing term. So I'm going to say A0 equal 15. A1 equal negative 5. And A2 equal 4. And A3, which is the last n, that means AN equal 1. So the combined matrix, we're going to write down the combined matrix, C, I think C to the P, okay. Combined matrix, the polynomial P is going to be, we're not going to start from AN. We're going to start from AN minus 1. That means this one. This is AN minus 1. So it's going to be 4, then negative 5, then 15. This is the first row. 4, negative 5, and 15. This is AN minus 1. This is AN minus 2. And keep going until A0. Then the next column is going to, in the next row is going to be 1, 0, 0, 0, 1, 0. It looks like the one of the identity matrices. The first row and the second column, the second row. So this one, what we're going to type here, the next step, you just have to find the determinant. So this is 4, negative 5, and here is going to be 15, and 1, 0, 0, 0, 1, and 0. This is for the first part. Now to find the characteristic polynomial for this one, you have to work on it. Exactly what we did, but now it's going to be the determinant of the combined matrix for P minus lambda I, which is equal the determinant of the combined matrix, which is 4, -5, 15, 1, 0, 0, 0, 1, 0, minus lambda 0, 0, 0, lambda 0, 0. That means this one is going to be equal the determinant of this matrix 4 minus lambda and -5 and 15. Then the second one is going to be 1. This is 0, so it's going to be negative lambda. And the third one is 0. This is going to be 0. And this one is going to be 1. And the last one is going to be 0 minus lambda is going to be negative lambda. Just find the determinant here. This is a plus, this is minus a plus. That means 4 minus lambda times negative lambda, 0, 1, negative lambda, minus -5, so it's going to be plus 5. This one, 1, 0, 0, negative lambda, 1, 0, 0, negative lambda, plus 15. The same thing is negative 50, plus 15 is going to be 1, negative lambda, 0, 1. Then this is going to be equal. This one is going to be 4 minus lambda. And here is going to be lambda squared minus 0, a plus 5. This is negative lambda. And the other one is 0, a plus 15. This is 1 minus 0. That means this one is going to be 4 minus lambda. And here is lambda squared minus 5 lambda plus 15. This one is going to be 4 lambda squared minus lambda cubed minus 5 lambda plus 15. Just write it down. Lambda cubed plus 4 lambda squared minus 5 lambda plus 15. That's it. That's what they're going to ask you. You don't have to find the eigenvalue and eigenvector. Let's end until here. Did we? We have here, oh yeah, plus 15. Okay, let's check this one, which is how we're going to type the lambda. I don't know. It's here. So it's going to be lambda, negative lambda cubed. Oh, we have to keep going back and forth. Cubed plus 4 lambda squared and minus 5 lambda and plus 15. Oh. So that's the wrong, I used the wrong because it's supposed to be negative sign. So this is negative This one is going to be positive because negative, negative. And this one is going to be negative. This is positive. So that was the wrong thing. That's mean when I find this is positive and this is negative. So when I find the matrix and this one is going to be negative 4, negative, positive, and here is negative. So negative 4 minus lambda, negative 4 minus lambda. Okay. Okay, this is right. And here's this one is right. This one is going to be positive 5 and negative 15. Okay, so now this one is going to be negative 4 minus lambda. And here is going to be minus 5. And here is going to be minus 5. And here is going to be minus 15. That's mean this is negative. And this one is going to be negative. And this one is going to be negative. So a negative 4. And this one now positive. And this one is negative. So it's going to be negative 4 lambda squared, positive lambda cubed, positive lambda cubed, negative. No, it's going to be negative lambda cubed. Why positive? And here is positive 5, and here is negative. So change the whole thing. That's mean negative lambda cubed minus 4 lambda plus 5 minus 15. Because the companion matrix theorem, it says you have to put negative sign here. That's what I did wrong. So that means this number is negative 4. This number is positive 5. And this number is going to be negative 15. Here is going to change everything. This is negative. This one, the second sign is also going to be minus. This one is going to be plus. And the last one is going to be minus. Let's check that. Here we go. It's just the sign here. I forgot it with the matrix. That's it.